This is a run-through of the released Fall 2012 Common Core Geometry Final, or the Common Exam. You will be taking one very much like it. Okay, here we go. The first example, or the first problem, we're told that both of these segments are tangent to the circle. That tells us two things. One is that we know they're congruent to each other because of what I call the ice cream cone theorem. And the other thing is we immediately know that each one of them is perpendicular to the radius that it touches. Okay, that's going to give us pretty much all the information we need to know. OT is 11. OT is a radius of the circle, and so the radius of the circle is 11. Well, so is OP, so is OS. And then we're also told that PR is equal to 60 centimeters. Okay, well, as you can hopefully see, this is a right triangle. And since it's a right triangle, we know two of the sides, and want to know the third side, we can use the Pythagorean theorem. 11 is the short side, or short leg, 60 is the long leg, and we want to know what is the hypotenuse. Pythagorean theorem. A squared plus B squared equals C squared. Okay, we have to find this strange area. It's kind of a strange shape. We don't exactly have a formula for it, but I hope you'll notice that this is simply the area of this large sector minus the area of this small piece right here. So, to find the area of the blue, we're going to take the area of the green and subtract the area of the yellow. It's just one sector minus another. You'll remember that the area of a sector is n over 360 pi r squared. And for the larger circle, the green sector, the area, the degree of the angle is 30 degrees. The radius is 6 minus, again, the area of the angle, or the degree of the angle is 30. And this time, the smaller one's radius is 2. And that is approximately 8.4. Okay, so we're doing transformations here. We want to map it onto itself. Okay, reflection over the line M. That is to say, this line right here. Well, if you just pick one point to reflect over the line, you go to the line at a perpendicular 90-degree angle, and then you go that same distance, the same point. Obviously, that's not mapped onto itself, so it's not A. Okay, a reflection over the line y equals 1. We're used to reflections over the line y equals x, and the x-axis and the y-axis, but it's pretty much done the same way. A reflection over the line y equals 1. Well, let me get up. Let's look at that line, y equals 1. Hopefully, you can see that if you were to flip this rectangle over this line, it would land on itself. So if I start here, I make a 90-degree angle, I went 5, I'm going to go 5 more. It takes me to itself. So this is looking pretty good. A rotation 90 degrees. Well, if you rotate this 90 degrees, it's going to end up like this it's going to end up the tall way instead of the wide way. So that's wrong. 270 degrees, same problem. Okay, so I'm going to start drawing them what they tell me. AB is parallel to CD. I don't even know what the question is yet. AB is congruent to CD. Okay, how do we know they're congruent? Well, we're going to obviously have to add a little bit more information. It's I hope you can see that ABD and CDB. They're talking about these two triangles. Clearly, they share this side, right, because of the reflexive property. And so we've got two sides that are congruent. Because they're parallel, hopefully you'll agree that this angle and this angle are congruent because they're alternate interior angles. And therefore, when I'm looking at the information I have, I've got a side, I've got two sides, and the angle in between. Two sides and the angle between, side angle side. Okay, HJ. Clearly, HJ is HI plus IJ, so we can figure each one of these out separately. This triangle right here is a 30, 60, 90. This is the short leg. So the long leg, which is this one, is the short leg times the square root of 3. Over here, this guy's the long leg, and I want to know the short leg, well, the formula is the long leg equals the short leg times the square root of 3. If I want to find ij, I divide it by the square, 80 by the square root of 3. Okay? And be careful how you plug this in the calculator, but basically you're going to add this to that, and hopefully you'll find that it's about 219 centimeters. Okay, we've got two ramps in this situation. Layla's ramp has a base that's 6 feet long, so we're going to assume these are right triangles. This is Layla, or her ramp rather. Okay, the ramp is 6 feet long, and the angle is 20.5 degrees. Casey built a ramp as well. I don't know if Casey is a boy or a girl. In any case, the base is 8 degrees, and the angle of elevation is only 16 degrees. We're still assuming a right triangle. They want to know, and it seems to be, they want to know about the height. Shorter, taller, height. They want to know about the height of these two ramps. So I'm going to call this C for Casey, and this L for Layla. And we'll use trigonometry to find these heights. Well, this is the angle, and the two sides involved are the opposite side and the adjacent side. So that's the tangent. The tangent of 20.5 equals opposite over adjacent. And to solve for that, I'm just going to multiply both sides by 6. 6 times the tangent of 22.5 is 2.24 feet, roughly. Okay, and over here, tangent of 16 equals C over 8. And so this one is approximately 2.29 feet tall. Okay, and so Casey's is taller, so maybe it's B. They're similar triangles. Of course they're not similar. They don't have the same angles. Layla's ramp is taller. No, it's clearly not. So either they're approximately the same height, or Layla's is 6 inches shorter. Well, let's see. If I subtract these two, 2.29 minus 2.24 is 0.05 feet. Okay, and if I want to convert that to inches, I'm going to multiply it times 12, and it's 0.6 inches, or 0.6 inch. That's less than an inch, so they're approximately the same height. Okay, this is a probability question. We did not cover probability. You're going to familiarize yourselves with what I've highlighted here. Let's move back real quick. So we want to know, is this independent? A and B are both going to happen. What's the probability? Well, if they're independent. If they're independent, then the probability of A and B is the probability of A times B. So that's what I need to be true if they're independent. If they're independent, the probability of A, well, in this case it's M and N. The probability of M and N both happening is the probability of N happening times the probability of N happening. Okay, so we're curious, is this true in this case? Well, the probability of M and N is 0.12. The probability of M is 0.4, and the probability of N is exactly 0.28. We're wondering, are these equal to each other? And if you plug this into the calculator, you'll see that this is 0.112, so they're not the same, so they're not independent, because P times probability of M times probability does not equal probability of M and N. Okay, again, these. On the next page, we're going to use conditional probability. The probability of A given B is the probability that they both happen divided by the probability that B happens. Okay, so it says, what's the probability that she took the bus given that she did not arrive late? So she was not late. Okay, so as I just pointed out, it's the probability of riding the bus and not being late. I guess I should write it this way. And not late, divided by the probability of B, that she's not late. Okay. Well, the probability, these are independent events. So the probability that she takes the bus is 80%, right? And they're independent because if she takes the bus, it's not going to affect whether the bus is late or not. It's not based on whether she rides or not. And the probability that the bus is not late. Well, the bus it arrives late 33% of the time. That means it's not late 67% of the time. So we've got the top. And now we've got to consider the probability that she's not late. Well, she could be not late riding the bus, or she could be not late riding the train. And these are independent, so we're going to add them up. We've already figured out the probability of her not being late riding the bus. And we're going to add to that the probability of her not being late riding the train. Let's see. So she's going to, if she rides the bus 80% of the time, she's going to ride the train 20% of the time. And if the train arrives, late 10% of the time, it's not late 90% of the time. When you plug this in the calculator, you're going to be careful to put the bottom in parentheses. All of the bottom in parentheses. That's approximately 75%. Okay, always produce a congruent figure. So we're looking for an isometry or a congruence transformation. Hopefully you'll remember that the three that are always isometries or congruence transformations are reflections, rotations, and translations. Here and here and here, we see evidence of dilation. This one is just a translation, so it's going to be a congruence transformation. Okay, they give us three vertices. This is the transformation rule, and we want to know what's going to be true. Well, as you can see, nothing changes about the x, but the y is multiplied by 1/5. The y gets smaller. So it says the perimeter will be 5 times. That means the image is getting larger, the perimeter is getting larger. I don't think so. Perhaps we'll just jot a real quick picture of this. 2, 5. So 2, 5, 12, 20, and 12, 5. So this is the pre-image. We want to know what happens. 2, 1. I'm multiplying the second coordinate by 1/5. 12, 4, and 12, 1. So clearly the perimeter is not larger. In fact, it's smaller. And the area is obviously not larger either. So it's going to be, what are we changing? Are we changing, the perimeter? Is the perimeter going to be 1/5 or is the area going to be 1/5? Well, I do want to point out just one thing. Perimeter you get by adding up all the sides. This side and this side, even though the triangle is smaller, the bases are the same. So it's probably not the perimeter that we're messing with. But look at the area of the triangles. The area of this one is, we'll say this is B and this is H. The area is 1/2 base times height. For the new guy, the area is going to be 1/2. His base is the same as that base, so it's base. His height, however, instead of being 15, is now 3. So his height is 1/5 of the other height times 1/5 height. So if you look at the two areas, the only thing that's different is this 1/5. So the area is going to be 1/5 the area of the pre-image. Okay, endpoints of a circle. What's the equation of the circle? Well, the first thing we need to do is find out the midpoint, or the center of the circle. It's the midpoint of these 2 points. We are going to add together 5 and 11 is 16 and divide by 2, so we get 8. 9 plus 17 is 20. 3 is 26, divided by 2 is 13. So that's the center. We need a minus 8 and a minus 13. These two work. And now this part's r squared. So I remind you that the equation of a circle is this right here. So we just know what the radius is. We're going to use the distance formula between these 2 points right here. So the radius is the change in x. They're 3 apart. What's the change in y? They're 4 apart. That's 5. If you square 5, you get 25. The answer is D. Okay. We did not talk about parabolas. That's an Algebra 2 topic. We actually talked about it in Algebra 2. But it doesn't matter. Even though you may have forgotten all about the focus and the directrix, you can figure this problem out. You don't even have to remember how to graph one of these things because the calculator will graph each of these for you. So what I've done is I've copied and pasted A, B, C, and D, what they look like on your calculator, and I've drawn over them our supposed directrix, which is y equals -5, and the focus, which is 2, -1. So this is the directrix, this is the focus. I hope you can look at A and see this parabola has nothing to do with these 2 points. So it's clearly not A. For B as well, I mean, there appears to be no connection there. I'm going to mark that one out. For C, our focus is up here and the direction is down here. This guy has a chance. The parabola actually appears to be somewhat related to that. And then also, maybe here, because it shows up between them. Okay, so even if you didn't know what's going on, you can reduce this to one of two choices. Now, I'm going to show you a GeoGebra real quick. Open recent, definition of parabola. I want to remind you what the focus and directrix are. The directrix, and I hope you can see the label here, the directrix is this red line right here, and the focus is inside. I remind you that, as I told you last year, the focus is kind of what the parabola, it's everybody in the parabola is kind of focused on this. It's in the middle, it's in the center. And just a real quick reminder, the definition of a parabola is all the points that are the same distance between the focus and the directrix. So regardless of where a point is on the parabola, it's going to be the same distance between this line and the focus. Okay, so back to this. Where does that leave us? Well, if I just look at the vertex, in this case it's 2 away from the focus and 2 away from the directrix. That's looking good. I think it's C. And over here, I can see that the parabola is only 1 away from the focus, and it's 3 away from the directrix. So there's a problem. It's not D. An isosceles right triangle is placed on a coordinate grid. Okay, so let's go ahead and do that. There's the coordinate grid. One of its legs is on the x and the other on the y. So we've got an isosceles right triangle that looks like this. Okay, which describes the shape created when the triangle is rotated about the x-axis. So here's our x-axis, and we're rotating the shape. So I want you to imagine the top of the y-axis going down, the bottom going up, and we're going to carve out a shape. Here's the other side of it when it goes past the bottom, but it's actually going to, I'm trying to draw it in 3 dimensions here. It's going to create this shape, and hopefully you can tell that that is a cone. A plane intersects a triangular pyramid, a regular triangular pyramid. So I'm going to draw a regular triangular pyramid, something like that. And a plane intersects it that is parallel to one of the faces of the pyramid. Well, the bottom's the base, the faces are the sides. So I want you to imagine a plane cutting through that's parallel to one of the sides. Okay, clearly I've created a triangle when I cut it, so it's not a square, it's not a trapezoid. And we just need to figure out if this is a right triangle or an isosceles triangle. We could prove this, but this time is one of the times we're going to just go with our eyeballing it. Clearly, I think these two sides are equal, so I'm going to guess isosceles. And if you're not comfortable guessing that's isosceles, I don't see how at all it looks like a right triangle. This would be the only one that could be a right angle, and that's only going to be in a very few cases. So it's not a right triangle. Okay, County X has a population density. We didn't talk about population density, but it doesn't matter. You guys can, they kind of tell you everything you need to know. They tell you that population density is measured in people per square mile. So that's going to be people over square miles. And they say the County X has a population density of 250. So I'm going to replace population density with 250. Its population is 150,000. So I'm going to replace people, or population, with 150,000 over the square mile of the county. Well, the square miles of a county is the area. So I'm going to put A for area, or just write area out. If I solve for area, it's going to be multiplied by area divided by 250. So the area of the county in square miles is 600 square miles. And so if I want to know which one of these models could be the shape of the county, I'm going to find the one that has the right area. I need an area of 600. Parallelogram is base times height. 25 times 25, its area is 625. That's close, but it's not exactly 600. A rectangle that is 15 miles wide, 15 miles long and 45 wide. Well, that's 15 times 45, which is 450 plus 225, 675. Again, close, but not exactly right. a right triangle with a leg that's 30 miles long and a hypotenuse 50. Let's draw that. Right triangle, leg that's 30, hypotenuse 50. Okay, here's where we're going to have to use Pythagorean theorem to find that this side is 40. And the area of a triangle is 1/2 base times height. 1/2 30 times 40 is 600. Looks like we have a winner. Let's go ahead and check out D while we're here. The area of a trapezoid is 1/2. The two bases are 10 and 30 times the height, which is 25. So that area is going to be 20 times 25, which is 500. So the answer is C. Okay, we've got to make a box. The smallest amount of cardboard. Let's draw the box. The box is going to be a rectangular prism, and the surface area of a prism is pH plus 2b. Okay, so we need to know the perimeter, the area of the base, and the height. Okay, so it says 24 cans and 2 layers of 12 cans each. So we need to imagine looking at if I want to find the area of the base of this box, I'm going to let the base be the bottom. If I want to find that area, I need to know how we've arranged the cans. Well, there's 12 cans in each layer, so maybe if I look from the top, our box looks like this. Maybe we have 12 cans in a row of 12 cans by 1. 7, 8, 9, 10, 11, 12. Now that's rather silly, but we've got to try all the possibilities. Maybe we have 2 rows of 6. 3, 4, 5, 6. 3, 4, 5, 6. Finally, maybe we have a row of 3 by 4. Or 3 rows of 4. Okay, from each of these, we can gather a different perimeter for the base and a different, or maybe not. Okay, so let's check it out. Perimeter. Well, the cans are 3 inches in diameter. That means this box would be 3 inches wide. It's 12 cans, so that's 36 long. So the perimeter here is 108. The area of the base is 3 times 36, which is also 108. I actually counted wrong. If I add up the perimeter, it's going to be 3 plus 36 plus 3 plus 36. So the perimeter is 78. Okay, option 2. 2 cans times 3 inches is 6 inches wide. 6 times 3 is 18. Perimeter here is 60 plus 48. I multiplied again. The area of the base is 108. Again, which makes sense. We have the same number of cans. The perimeter is going to be 48. It's 6 plus 18 plus 6 plus 18. And finally, here we have 9 and 12. The perimeter is going to be 21 times 2 is 42. And the area of the base is still 108. So if I want to use the least amount of cardboard, I'm going to need the one with the smallest perimeter. And that is this option. So let's find the total surface area. The perimeter of our base is 42. The height. Oh, I didn't think about that. Well, it's 2 cans tall, and each can is 5 inches in height. So the height is 10. Plus 2 times the area of the base. The area of the base is 108. 216 plus 420 is 636. Okay, this is probability. We didn't talk about probability that much, although we did, even in geometric probability, we learned that probability is what you want to happen over what can happen. Okay, so it says, what's the probability a randomly chosen student from the senior class? That tells us a student from the senior class. That's whom we can pick. We can pick somebody from the senior class. Is a girl who does not run track. Girl, no track. Okay, well, let's think about this. How many people are in the senior class? 250. And now we need to know how many are girls who do not run track. Okay, well, first we need to figure out how many girls there are. 102 are boys. 250 minus 102 means there are 148 girls. But we need to number the girls who don't run track. Well, 20 run track, so it's going to be 148 minus 20 who don't run track. 128. That's not one of our options, but if we, it's just over half. 0.512. So here we go. Okay. Okay. This is another probability question. So we've got 21 students at the school who have an allergy, and peanut shell pits are both. So let's draw a Venn diagram to picture this. So these are the students who are allergic to peanuts, and these are the students who are allergic to shellfish. And obviously the ones in the middle are allergic to both. That's what we know. How many are allergic to both? All right, well, we know there's 21 in all, 14 in this circle, and 12 in this circle. Well, if I added all these up, maybe if there were none in the middle, then I would add that, and I'd get 21. But I don't. If I add the 14 plus 12, I get 26, which means I've counted 5 too many. That means 5 are in the middle. Okay? If 14 are allergic to peanuts and 5 are in the middle, that means 9 are over here. If 12 are allergic to shellfish, there's 5 in the both categories, so there's 7 over here. If you add up these, that's 21, and 5 are allergic to both. So that's C. The frequency table below shows the age of distribution of people in the park. Another probability question. But again, if you just remember want over can, you'll be fine. Okay, probability that we pick, it's a female, given that the person is under 40. Under 40, so less than 40. Okay, you could use the formula that I showed you earlier, or you can just remember want over can. We want to pick someone under 40, but they're female and under 40, so female under 40. And we can pick, they said, given that the person's under 40. All right, so how many people in the park are female and under 40? That's going to be these two categories. This is the under 40. The females are 42 plus 18. There are 60 of them. Now we know the person's under 40. How many people are under 40? We're going to add all of these up. 60, 110, 128. Okay, that's not an option, but if we divide it, the top and the bottom by 4, we get B. We're almost done. 6 more to go. A city map is placed on the coordinate grid. The post office is located here, library here, fire station here. They want to know the ratio of the length of PF. Well, we write the length of PF like that over the length of LF. We write that like that. How do we find these? And this is going to be the distance formula. So PF. Here's P and F. I want to see 5 and 9 are 4 apart. Plus, let's see how far apart the Y's are. 35 and 25 are 10 apart. I'm only doing the top row right now. That's the square root of 116. Okay, that's kind of ugly. I'm just going to leave it like that. I'm going to let the calculator do most of the work here. For LF, I need to figure out the difference between the x's, L and F. 15 and 9 are 6 apart. And the y's are 15 apart. That's going to be the square root of 225 plus 36 is 261. So let's plug that in the calculator. I can't access the top. Oh, well. Okay, the square root of, I hope I remember this, 116. I'll have to turn it on first. Square root of 116 divided by the square root of 261. 0.666. Hopefully you recognize that as 2/3. So the answer is A. Center of a circle, 0.12 lies on the circle, and what's also on the circle. You could guess at this, but I don't recommend it. I recommend trying to write the equation of the circle. We know the standard form looks like this: x minus h squared plus y minus k squared equals r squared. Well, we can write most of this to begin with. The center that's our hk, so it's x minus negative h, or negative 4 squared, plus y minus 2 squared equals, oh, I don't know the r. Okay, well, if 0.12 is on the circle, then the radius is going to be the distance between those two. Let's figure that out. The radius is, well, the change in x, 1 and negative 4 are 5 apart. The change in y is 0. So the radius is just 5. So I always have to square the radius, so that's the formula. And basically, you're just going to plug in these 4 points into the left side of the equation and see which gives you 25. 9 plus 9, that's square root of 18, that's wrong. I have the answer under somewhere. It's not A. For B, it's going to be 0 plus 9, that doesn't work. Negative 1, negative 2, that's 5 squared plus, nope, that doesn't work. It's looking like 0, 7, 4 squared plus, no, that's not it either. try C again. Negative 1 plus 4 is 3 squared is 9. Plus negative 2 minus 2 is negative 4. Negative 4 squared is 16. That equals 25. 25 is C is our winner. Okay, we want to know that LMN, this triangle, can be transformed and mapped onto that one. Well, we can work with congruence transformations, but we also are going to have to use dilations. This is big, this is small. We're going to have to dilate at some point. Okay, well, all we need to know is that these two triangles are similar to each other. There are 3 ways to prove triangles are similar. Angle-angle similarity, side-angle-side similarity, and side-side-side similarity. Okay, hopefully we can use angle-angle. Let's see. OQ is 6. Well, if OQ is 6, in that situation, we can't use side-side-side because we don't know all 3 sides over here. So our only option will be side-angle-side, but we don't know the side that includes this angle, the only angle we do know. So it cannot be, that information is useless. I don't need to know about OQ. Maybe MN equals 9. Okay, now we're talking. Okay, so obviously we're going to use side, angle, side, side, angle, side. Let's see if that works. Well, the angles are the same. That's good. Now we have to check to make sure that the side lengths are proportional. So is the 12 over here and the 8 over there, is that equal to the 9 to 4? They're not equal. So it's definitely not that. I'm going to go ahead and mark that out. Mark out B. Okay, now we're talking about angles. Good. LMN, that's this angle, is congruent to QOP, this angle. I don't know about that. And in any case, that would only give us one angle is equal to another angle. In LM, that's this angle, is congruent to QOP, that's this angle. Okay, at this point, I would know that 2 of the angles are equal to 2 of the angles, therefore they're similar. Therefore, I can transform one onto the other. All right, 3 more to go. Angles F and G are complementary angles. So I want you to think about how they're related. We're talking about the sine of F and the cos of G. So sine of, let's just pick an angle, 60. I want to see how that's related to the cosine of G. Well, if G and F are complementary, that means G is going to be 90 minus 60, or 30. So let's look at these two. You actually should know these. Maybe you should know these in your head, but wrong button. Sine of 60, make sure you're in degree mode, is 0.866. Let's try the cosine of 30. Cosine of 30. Oh, they're the same. They are the same. So the sine of F is equal to the cosine of G. So if sine increases by 0.2, what does cos do? It increases by the same amount because they're equal to each other. Alberto and Janet start running at the same time in a straight line path. This is really an Algebra 1 problem. I'm not sure why they stuck it in here. We want to know how long it's going to take Alberto to pass Janet. Well, let's try to put their speeds in the same unit. So Janet, we're talking about seconds here. Seconds. Feet, inches. Let's convert everything to feet per second. Janet is running at 6 yards per second. 6 yards, well, multiply yard by 3 to get a foot. Janet's running at 18 feet per second. Okay, let's talk about Alberto. How fast is he running? He is running at 1440 feet per minute. Well, I don't want feet per minute, I want feet per second. Feet per minute is way too fast, so 1 minute is equal to 60 seconds. So to figure this out, I'm going to need to divide by 60. So that's 24 feet per second. Okay, so Alberto is catching up at a rate of 6 feet per second. Well, how far behind is he? He's 1,080 inches behind Janet. How many feet is that? We're just going to divide inches by 12 to get our feet, 90 feet. So he's 90 feet behind her, and every second he catches up 6 feet. So 90 feet divided by 6 means he'll catch up with her in 15 seconds. And then finally, the edge of a ruler. Paul used to measure the radius of a circle. Blah, blah, blah. How to report the area. This is about precision, okay? I'm going to give you a very quick lesson of precision. That is, if your information has 3 significant digits, your answer needs to have 3 significant digits. So it's not A, it's not B. We're talking about the area of a circle. Well, that's pi r squared. The radius, we're going with 375 squared. That is equal to, calculator, please, pi times 3.75 squared. 44.17. Oh, we're going with 3. 44.2. C is the answer. I am going to put, please use pi instead of 3.14. It's much more accurate. And that is all.